In this entire class of mechanics, there really is only 4 kinds of problems that we can ask you. The purpose of this video is to first identify these 4 different kinds: momentum and the conservation of momentum, energy and the conservation of energy, dynamics, and kinematics. In most physics classes, they teach students about these 4 kinds of physics problems first, and then only at the very end of the class distinguish the 4 different kinds of physics problems. We're going to do it differently. We're going to start by identifying first the 4 different kinds of problems and then develop that step by step to a full picture of mechanics. Okay, so your learning objective is, when you're looking at an event, can you identify what's happening with each of the above: the momentum, the energy, the dynamics, and the kinematics? Okay, so what are they? Momentum. Momentum is mass times velocity. It can be thought of as how hard it is to stop something. Momentum is always conserved in a system unless something from the outside pushes on it. However, momentum can be transferred from one object to the other in a collision. So here we have 2 carts on a track, a red cart that's moving and has momentum, and a blue stationary cart with no momentum at all. So momentum is conserved. The momentum in the beginning in the red cart is equal to the total momentum of the 2 carts together. And so another way to look at this is to say that the red cart has lost some momentum and given it to the blue cart. Or you could say the total system still has the same amount of momentum, but in the beginning it's all in the red cart, and at the end it's the 2 carts together. And because the mass of the red and blue cart together is way bigger than the mass of the red cart alone, the velocity drops. Energy. Energy, like momentum, is conserved, so unless you add energy into a system, the total amount of energy will always be the same. However, inside of the system, energy can be transferred from one object to the other. And very importantly, unlike momentum, energy can change forms. This guy stores his work in the elastic potential energy of the funnelator and then lets it go, and that elastic potential energy turns to kinetic energy of the moving water balloon. So the flow of energy goes from the man to the elastic cords, and then from the elastic cords to the water balloon. The energy also changes forms. It starts with the work of the man's arms putting energy into the funnelator system. So the work of the man's arms is converted to elastic potential energy in the cords, in the elastic cords, and then when he lets it go, it's converted from elastic potential energy to kinetic energy of the moving water balloon. Dynamics simply means when you put a force on something, it's going to accelerate. So if I put a force on Neil in this direction, he accelerates in this direction. Even if he's moving already, if the force is in this direction, the acceleration is in the same direction. If the force is in the opposite direction, the acceleration is in the opposite direction. Let's see that again. His velocity is still to the right, but the acceleration is to the left, reducing his velocity. And if there's no force, that is, if the force is 0, the acceleration is 0, and we continue at a constant velocity. Dynamics simply means when you put a force on something, it's going to accelerate, or we know F equals ma. Kinematics is simply when we look at our position and our motion and explain it with math. So let's say that this is 0 meters right here. Therefore, Neil would start at 2 meters, and he's moving along at a constant velocity of 3 meters per second. Every second, he moves 3 meters. So after 1, 2 seconds, he should have moved 6 meters and is now at 8 meters. Okay, so when you look at a problem, Can you tell us what's happening with the momentum? Can you tell us what's happening with the energy? Can you recognize the dynamics? And if it's moving, can you tell me what the kinematics are? You don't have to do it all today. We have a whole quarter to learn this.